Math 2312, Chapter 1, Functions, Section 1, Functions and Function Notation, Video 9, Invertible Functions. Before I start this next section, I will admit that this first section of this first chapter of this particular textbook really reviews a lot of function ideas from, say, a college algebra class. Of the things we've talked about so far in a college algebra class, this would have covered 1, 2, 3, at least 4 sections in a college algebra class, whereas all of this is kind of summarized and reviewed in one section. So I want to assure you that as we move forward through more sections and more chapters, there won't be so many different topics just in one section. And some of the things we've talked about, we are going to go into more detail later. All right, so what do I mean by invertible functions? Well, first, the setup. Suppose f of x is 1 to 1 with domain D and range R. So think of it this way. We've got this blob here, this space, this lamina, if you will, representing the domain of the function. So inside of it are all the numbers that we can put into the function. And in this lamina over here, we're representing the range, meaning all the outputs. So we can illustrate the function doing its thing by picking an element in the domain, let's call it x, and pointing it to its corresponding output in the range. In other words, we're saying y is equal to f of x. By pointing x to y, x in the domain, y in the range. Now, what does it mean to be a function? What it means to be a function is that this x can't go to another place. We'll say z, just to give it a different name. That would not be a function. This would be one input with 2 outputs. That can't happen. Every element in the domain has to have only one place to go. But if this were any old function, there might be another x, and we'll call the first one x1 and the second one x2. From a function perspective, there's nothing wrong with that. This x has one place to go here, so does that one. Just happens to be the same output. That doesn't violate being a function, but it does violate being 1 to 1. 1 to 1 says if your outputs are equal, so are your inputs. And in this picture, we have 2 different inputs with the same output. So if you're a 1 to 1 function, that means if you have a domain element pointing to you, if you're in the range and you have a domain element pointing to you, if you're 1 to 1, that is the only domain element pointing to you. So in other words, if you're 1 to 1, not only does y equal f of x, and this is the only x such that y equals f of x. So you're my input and nobody else is, because I'm a 1 to 1 function. One input for every one output and vice versa. So let's say we have a situation where every output, every element in the range has precisely one element in the domain that corresponds as an input. Well, doesn't that mean if we go backwards, we can think of it as a function? Like, for example, pick a number here. We'll call it z. Why? Why not? Assuming that you have an input, we'll call it w. Assuming that you have an input, that's the only input you have because you're a 1 to 1 function. So we can almost think about this function going backwards, saying that every guy over here points to only one guy over here. And that going backwards would be called the inverse function. Suppose f of x is 1 to 1 with domain D and range R. Then there exists an inverse function, and the notation for it is f superscripted with what looks like a -1 power, but it's not a power. It's read f inverse of x. F inverse of x. With domain R and range D, that's sounds backwards, but what we're doing is we're defining a function in reverse. In other words, we're defining a function that picks something over here and points it over there. And because it's 1 to 1 going this way, it's only got one place to go backwards. This guy would point there. There exists an inverse function, and we're calling it f inverse of x, with domain R and range D such that if f of x is equal to y, then f inverse y is equal to x. Essentially, the inverse function undoes what the original function does. Let's say I'm a function and I'm 1 to 1. You give me a number, like let's say you give me another number 5, and I'm not going to tell you what I'm going to do to the 5, but when I'm done with it, it turns it into a 17. If I'm a 1 to 1 function, then there's another function that says, well, I'll take the 17, I'll undo what you did, and give you back the 5 that you started with. So it undoes the original function, but it can only undo the original function if the original function was 1 to 1 to begin with. For example, go back to x squared. Remember x squared, it took 7, and when it squared it, what did it turn it into? 49. But it also took negative 7 and turned it into 49. There's no inverse function to this, because if I'm a function that squares something, give me a number I'll square it, here I'll give you back the 49. You don't know what number I started with. Did I start with a 7? Did I start with a negative 7? You don't know. I'm not a 1 to 1 function. I could have been either one. So if I have a function that's going backwards, the function that says give me the 49 and I'll give you back what you started with, I don't know what to give back to you. Because you might have had a 7 or a negative 7, and well, I can't undo you because you weren't a 1 to 1 function. And since I can't undo you, I don't know what one number to give you back. I'm not a function, because the original was not 1 to 1. So the idea of an inverse function is I'm going to undo what you did. I'm going to be a function that undoes what an original function did. But it can only happen if the original function was 1 to 1. Now, we're going to conclude this video by trying to figure out how can you locate a function's inverse assuming it does have an inverse. And in order to have an inverse, you have to be a 1 to 1 function. And we've already seen one of those. The function was f of x equals 3x plus 1. We already know this is 1 to 1. We proved it algebraically, but it also passed the horizontal line test, which I'm going to abbreviate HLT. And we're going to find its inverse. In other words, find the function that undoes this. Now, some functions are small enough that you can talk yourself into it. Think about it. What does this function do? I give it a number. What does it do in what order? It takes a number, multiplies it by 3, and then adds 1 to it. Let that sink in. Take a number like 5, multiply it by 3 to get 16. Wait. Multiply by 3 to get 15, then add 1 to it to get 16. How can I reverse that process? By reversing each step in the reverse order. The last thing I did to the 16 was add 1 to it. So how do you undo adding 1? Subtracting 1. 16 minus 1 is 15. The first thing I did to the 5 was multiply it times 3 to turn it into the 15. How do you unmultiply by 3? Divide by 3. The inverse function, f inverse of x, will take a number, subtract 1 from it, and then divide by 3. This function will undo what this one does. Think about it. In order, this function will go times 3 plus 1. This function will undo the plus 1, followed by undoing the times 3. Now, I'd be kidding if I'd be lying to you if I said the only way you can find the inverse of a function is to talk yourself into it, because there are some invertible functions that aren't easy to look at and go, that's its inverse. There's got to be a more predictable, objective way of getting from a function to its inverse. And of course there is. The way to find the inverse of a 1 to 1 function, you can do it in some pretty simple steps. Actually, all you have to do is, well, I'll show you. The first thing you do is change f of x to y. I'm trying to be real careful not to reteach an entire college algebra lesson, so consider this a review. Change f of x to y. Step 2, switch x and y. By switching x and y, what you're basically doing is switching the domain and range, sort of. If I switch the x and y, it says x equals 3y plus 1, and then all you have to do is solve for y. I can solve this for y in 2 moves. Subtract 1 from both sides to get x minus 1 equals 3y. Divide both sides by 3 to get y equals x minus 1 over 3. At that point, you found your inverse, and all you have to do is change y to f inverse of x. F inverse of x. Therefore, f inverse of x is equal to x minus 1 over 3. If you can rewrite the function as y equals, switch the x and the y, and then solve for the y, you will find the inverse function. In my mind, I'm thinking as a college algebra video, what we just did would not be a video, it would stem from a series of videos, but this course is assuming that you have some college algebra background already. So, sorry.